Aluminum is everywhere. Soda cans, airplanes, solar panels. It's the most abundant metal in Earth's crust. So why does it take so much effort to produce? To make aluminum, you don't just melt rock, you dissolve it in caustic chemicals, heat it to nearly 1000 degrees Celsius, and then run an electric current through it. For every ton of aluminum, you burn enough electricity to power a house for a year. Why is something so common, so hard to make? The story of aluminum starts with a rock, bauxite. Unlike gold or copper, aluminum never shows up as shiny nuggets. It's always trapped inside bauxite, a reddish ore made of aluminum hydroxides, iron oxides, and other minerals. In the late 1800s, chemists cracked the code. Carl Baer invented a chemical process that could transform bauxite into aluminum oxide, also called alumina. The method? Crush the rock, mix it with boiling sodium hydroxide at 150 degrees Celsius and 5 atmospheres of pressure. The aluminum dissolves, the iron stays behind. Then the mixture is cooled, filtered, and what's left is a fine white powder, alumina. But don't celebrate yet. You need 4 tons of bauxite just to make 2 tons of alumina, and that's before you even make metal. Turning alumina into aluminum metal is a whole different beast. Enter the Hall-Héroult process, invented in 1886, still used today. First, dissolve the alumina into molten cryolite, a rare fluoride compound, heated to 950 degrees Celsius. Inside giant electrolytic cells, carbon electrodes are lowered into the molten bath. When electric current flows through, aluminum ions sink to the bottom and form molten metal. Oxygen ions rise and burn the carbon electrodes, producing CO2 in the process. That means aluminum smelting emits carbon not from fuel, but from chemistry. And the electricity demand? 1 ton of aluminum takes 14,000 to 16,000 kilowatt hours to produce, enough to power an entire household for over a year. That's why you'll find aluminum smelters in places like Iceland or Canada, where hydro and geothermal power make this electricity-hungry process viable. Aluminum, in a way, is solid electricity, but it's also incredibly fragile, economically speaking. A rise in power prices, it can bankrupt entire smelters, but there's another hidden cost to all this. A sludge called red mud. For every ton of alumina produced, we generate up to 1.5 tons of this waste. It's caustic, corrosive, full of heavy metals and residual sodium hydroxide, and we don't really know what to do with it. Globally, over 150 million tons of red mud is generated each year. Most of it is stored in ponds or dry stacks, behind dams. But if those dams fail, the results are devastating. In 2010, one did, in Acre, Hungary. 1 million cubic meters of red mud flooded towns, resulting in huge environmental damage. After decades of research, only 5% of red mud is reused. The rest just piles up. Now the good news, aluminum is one of the few materials we can recycle infinitely. It never loses strength, and it takes just 5% of the energy compared to primary production. That's why 75% of all aluminum ever made is still in use today. Soda cans, airplane parts, power lines, bike frames. One recycled aluminum soda can is enough to power a laptop for 3 hours, and most cans, they're back on store shelves in just 60 days. Aluminum recycling is not just eco-friendly, it's profitable. In the US alone, it generates over $1 billion annually. So why do we still mine bauxite? Because demand is exploding, driven by electric vehicles, wind turbines, and data centers, and recycling can't keep up, yet. Today, aluminum isn't just a metal, it's a geopolitical battleground. China produces over 60% of global aluminum. Why? Because it's scaled quickly and used cheap coal-powered electricity. Meanwhile, countries like Canada, Norway, and Iceland use renewables to make cleaner aluminum, but at higher costs. That's the paradox. The cleaner the aluminum, the more expensive it becomes. In 2021, when energy prices spiked in Europe, smelters shut down across the continent. In some regions, it's cheaper to import aluminum than to make it yourself. But that may be changing. Aluminum is now classified as a critical mineral, just like lithium or rare earths. Why? Because it's essential for EVs, wind turbines, aircraft, and even tech. Innovation is catching up too. Projects like ELYSIS, backed by Apple and Alcoa, are testing carbon-free smelting with inert nodes. If it works, we could make aluminium without CO2 emissions at all, but we're not there yet. For now, it's a tug of war between cost, carbon and control. Aluminium is a metal full of contradictions. It's everywhere, but hard to get. It's infinitely recyclable, but creates toxic waste. It's vital to the green economy, but made with massive emissions, from the red mud lakes of Hungary to the hydro-powered smelters of Iceland. From soda cans to space shuttles, aluminium shapes our world. But if we want to build a cleaner future, aluminium has to get cleaner too. That means smarter tech, better recycling, and, most of all, cleaner energy. So the next time you hold a soda can, remember, you're holding refined rock, frozen electricity, and a glimpse into the future.